There are some occasions when one might want to combine several rather than use just one indicator of a construct that cannot be directly observed. Assuming that each of the indicators is valid, the usual reason given for preferring the combination of multiple over single indicators is that the combined measure will be more reliable than any one of the single indicators. Another way to put this is to say that it boosts the ratio of signal to noise. In a moment, I will discuss several of the ways that have been proposed to combine multiple indicators into a single summary indicator. But before I do that, I want to make a conceptual distinction that is often neglected, but is actually quite important if one wants to think clearly about what one is doing. When we talk of constructing a scale out of a set of items, say a set of attitudinal statements, which respondents are asked to respond to by saying how much they agree or disagree with the statements, our underlying idea is usually something like the following. There is a construct that we are unable to directly observe, say authoritarianism. We can think of this construct as a latent tray or dimension on which people will take different values. We want to estimate for each person what that value is. The value describes how authoritarian they are. All we have to go on are their observed responses to a number of statements that have been chosen because we believe they measure the underlying tray. The implicit model is that the unobserved tray, here represented in the left-hand panel by a blue circle, is the cause of the observed indicators, represented by the blue boxes. Responses to the indicators will be observed to be positively correlated with each other. For instance, in the case of authoritarianism, we might expect people who favour strict obedience in children to also tend to favour restrictions on the type of books that can be published and on the right of people to take part in political protests. These correlations will obviously not be perfect, but exist because of the joint dependence of the observed responses on the latent tray. This idea is formalised in some common statistical models, for example, factor analysis and latent tray analysis, where a key assumption is that conditional on the latent construct, the observed indicators are statistically independent of each other. If this assumption is reasonable, it leads to the possibility of using some very powerful data reduction techniques to simplify the analysis of complex data. I'm not going to discuss these here, but the key takeaway for our purposes is that in this way of thinking, the direction of causality is assumed to flow from the construct or tray to the observed indicators. In essence, people give the responses they do because of their position on the underlying unobserved dimension. It is probably worth saying that the construct need not represent something with a physical existence. This is not a place to open up an ontological discussion of the nature of social attitudes. For our purposes, it's good enough to say that an attitude is a propensity to respond in a certain way when presented with certain stimuli. These responses may be verbal or they may be physical. What this propensity actually is may be difficult to say, but for many practical purposes it may be sufficient to treat it as nothing more than an analytical convenience that helps to simplify the account we give of certain observable behaviours. Now consider the right-hand panel labelled Index. This looks very similar to the Scale panel. The main difference is that the arrows from the observable indicators point towards the blue circle. When we talk about an index, we usually do not have in mind that the observed indicators are caused by some unobserved latent tray. Take the example of socioeconomic status, SES, a term used a lot in American social stratification research in circumstances where a European might more often talk about social class. What is SES? Well, usually it's some sort of composite measure based on things like education and income, possibly combined in some weighted way that the investigator has decided she will use to define what SES means. Notice the analytical move. There is no assumption that SES causes education or income. Rather, the assertion is that income and education, in a weighted combination, define what for the investigator SES is to mean. It is in this sense that indices are attempts to combine together apples and oranges, because for the purpose of a particular investigation, the convenience of doing so outweighs the disadvantages. The observed indicators are sometimes called causal indicators. Bolan uses this term in several of the articles on your reading list. Conceptually, at least, the direction of causality flows from the indicator to the composite construct. One consequence of this way of seeing things is that it implies that the observed indicators need not necessarily be correlated with each other. When we are choosing items with which to build a scale, it is sensible to examine how all the proposed items are correlated with each other. Normally, if some appear only to be weakly correlated with the rest, we might suspect that those items do not belong in the same scale. There are, of course, more formal ways of interrogating correlation methods than simply scanning them visually. Principal components analysis and factor analysis, which are, by the way, not the same thing, are often employed for this purpose. However, in the case of an index, there's actually no necessity or even reason to believe that all of the causal indicators will be correlated with each other. They are not a function of the index and can, in principle, have more or less any relationship with each other. There are two possible things that could be scaled when we are in the business of trying to measure subjective phenomena objectively. Different methods of scaling either attempt to locate the individual subject on the latent dimension of interest, or attempt to simultaneously place both the subject and the item they respond to on such a scale. What it means to locate a subject on a latent dimension is reasonably clear. If the latent dimension is, say, liberal authoritarianism, then we want to know if an individual is more towards the liberal end or more towards the authoritarian end. Locating items on the dimension is perhaps not quite so clear. The idea is that in some circumstances it's reasonable to think that agreeing or disagreeing with some attitudinal items indicates a more extreme position on the dimension of interest. Clearly, the statement that people should be fined for dropping cigarette butts in the street is less extreme than the statement people should be executed for dropping cigarette butts in the street. Some of the earliest attempts to construct scaling methods involved simultaneously scaling subjects and items. Some sophisticated statistical methods still do so, but it is now much more common, at least in the domain of attitudinal research, to use methods that only scale subjects. I'm now going to discuss three scaling methods that regularly feature in the methodological literature: Thurston scales, Gutmann scales, and Likert, or summated ratings, as they're sometimes known, scales. Of these, the first two are mostly of historical interest. Gutmann scales are very occasionally used in modern survey research, but the workhorse technique is now almost universally Likert scaling. Let's first look at Thurston scaling, named after the American psychologist Louis Leon Thurston. Let's say that the underlying trait to be measured is favourability towards the EU. We begin by inventing a number of items that we think will indicate the respondent's degree of favourability towards the EU. Typical items might be: I believe the EU is a powerful agency for promoting the economic welfare of all Europeans. Or, I believe each European state should be free to defend its interests without excessive interference from Brussels. Or, I think the EU is an affront to democracy. Each subject is asked to endorse only those items she agrees with. So, the basic idea is rather straightforward. However, the method of constructing the scale is rather tediously involved. First, we need to create an item pool consisting of items that span the complete range of responses, from very favourable to very unfavourable. It is reckoned that this pool should consist of at least 100 items. Then, around 50 judges sort the items into, say, 11 sets. They are instructed to do this so that the sets are ordered with equal intervals along the target dimension. Of course, what an equal interval is will be entirely a subjective matter for each of the judges. Next, each of the sets is scored, say with an integer value indicating their rank order from 1 to 11. Individual items will then receive the median score, with the averaging being over the rankings of the 50 judges. Naturally, there will be some items about which there is a lot of disagreement between the judges. In that case, the variance of the scores will be large. These items are discarded. About 20 of those that remain, chosen to cover the entire range of scores, are selected for inclusion in the questionnaire, where they're printed in a random order. Subjects, or respondents, are asked to endorse only those they agree with, and their scale score becomes the average of the numerical values of the endorsed items. Gutmann scaling, named after the American sociologist Louis Gutmann, takes a very different approach to using multiple items to build a scale. The basic idea can be illustrated by Emery S. Bogardus's social distance scale, first developed in America in the 1920s. The purpose of the scale is to measure a person's willingness to accept social contact with people from a different social or ethnic group. Say the target for the rating is ethnic group X. Subjects are asked a sequence of questions, each one representing a distinct step in acceptance. So a typical sequence might be to ask whether the subject would accept members of group X as close relatives by marriage, as my close personal friends, as neighbours on the same street, as co-workers in the same occupation, as citizens in my country, as non-citizen visitors in my country. The subject is asked to respond yes or no to these, and the set is said to be scalable if a yes answer to an earlier statement implies a yes answer to a later statement. In other words, it should not be possible for someone to say that they would accept an individual of group X as a close personal friend, but not permit them to live in a neighbouring street. If this assumption about the way people will respond to the items is correct, then we should find that only the patterns of response corresponding to the so-called perfect scale patterns will be observed. In this example, there are 7 subjects and 6 items. Subject A answers yes to all 6, and her scale score is 6. Subject E answers yes to 2, and her scale score is 2. It is, of course, important not just that she answers yes to 2 items, but that she answers yes to the first 2 items. A nice feature of the Gutmann scale is that the scale score tells you both how many items are endorsed, but also which items are endorsed. Gutmann scales are an elegant solution to the problem of turning an array of answers into a scalar quantity. Unfortunately, they're not designed for the world we actually live in. In this slide, we can see a rather typical set of outcomes. Here there are 4 items and 16 subjects. Agreement with an item is indicated by a plus sign, and disagreement with a minus sign. Though the responses of some of the subjects correspond to the perfect scale types, or for example the first and second rows, there are many that do not. There are a number of reasons why discrepant scale patterns might occur. One is simple random measurement error. Some respondents may just make a mistake in their response. Another possibility, and this is in a sense what the technique is meant to discover, is that the items are just not scalable, because they do not map neatly onto one single underlying latent dimension. Population heterogeneity in the way the items are understood could also be another reason. Occasionally one sees Gutmann scales being employed in social surveys, but these days they are becoming a rather rare occurrence. By far the most common method of producing a scale in modern social survey research is to use so-called Likert items. These consist of a statement such as, for example, "The EU works in the best interests of all Europeans." And in addition to the statement, a response scale with responses ranging from agree strongly to disagree. The subject's score on that item is simply the numerical value that corresponds to the verbal formulation on the response scale that they select. In this case, 1 for agree strongly and 5 for disagree strongly. It would be typical to put to the respondent a set of statements, say 6 to 10, about the object of interest, in this case the European Union, and for each individual to simply add up the scores to yield a total scale value. Of course, in doing so, it is necessary to pay careful attention to the polarity of each item. In other words, whether an agree response indicates a favourable or a disfavourable disposition towards the object that is being rated. There is a large technical literature, largely of interest to social survey professionals, about a number of issues concerning the use of Likert type scales. For example, how many response categories should there be? Should there be 5? Should there be 7? Should there be 11? Secondly, should there be a distinct middle response category indicating neutrality or ambivalence, implying, of course, an odd number of response categories? Or should an even number of response categories be used, thus forcing subjects, as it were, to choose sides? A third issue is, should a don't know response be permitted? And if it is, does it mean something different to the neither agree nor disagree response? All of these are extremely interesting questions, but if you want to learn more about them, you're going to have to consult the technical literature. One issue that we should take up here, though, is slightly more foundational. This technique looks as though it shouldn't really work. It appears to assume that we can take what is at best a set of ordinal rankings, add them together, and construct an interval level score from them. Logically, this seems, to say the least, a little opaque. However, in practice, we have good evidence that summated rating scales constructed from Likert-like items actually perform very well and are often much more reliable than Thurston or Gutmann scales. In fact, they often do as well as many of the more sophisticated and complex statistical techniques that can be used to produce scale values. Summing together a set of items returns us again to the question of reliability. How can we assess reliability when we're dealing not with two, but with many items? The conventional answer is to make use of something called Cronbach's alpha. If we can assume that the individual items have roughly equal variances, Cronbach's alpha can be approximated by this simple formula, which in effect makes it a function of the average inter-item correlation. Alpha takes a value on the 0-1 interval, with higher numbers indicating greater reliability, in other words, greater agreement between the different constituent parts of the scale. Alpha approaches 1 at a diminishing rate as more items are added into the scale, as long as the addition of an item does not reduce the average inter-item correlation. You'll often see it used in a somewhat ritualistic, what I sometimes call Snoopy blanket fashion, in articles to assure referees and readers that whatever the author has done passes some arbitrary threshold of acceptability. In fact, it's very difficult to determine what a reasonable value for alpha should be. It's probably best regarded as setting a lower bound on reliability, which is clearly Louis Gutmann's intention in his discussion of the measure. One thing that it's important to realise is that it's perfectly possible to get identical alphas from correlation matrices with very different structures, and that alpha will tell you almost nothing about the dimensionality of a set of items. The issue of whether a set of items belongs together needs to be settled before evaluating the reliability of the item set. In short, coefficient alpha can be a useful tool, but it needs to be used with intelligence.